Assalamu alaikum and welcome to the second video that we will explain how to use the Seismic survey software. In this video I will focus mainly on the Seismic GNSS importer, and we start to make a new project and create a new database if we don't have a database, or select an existing database if we already have. So the first one we will start is the GNSS importer. When you open the application for the first time, it will show you all the recent projects that you have worked on, and you can open any one of these, or you can start a new project. For me, I prefer to open an existing project, then we make save as, so we don't lose our setting, QC setting and everything. But for you, I will start with a new project. First thing we want to do when we start a new project is to save our project. So I will save a project. For example, I will create a new folder here, Seismic Survey Training. Okay, we have it. The second thing is to select the coordinate system. You have a lot of coordinate system groups for different countries. Also, you have some coordinate system is the world coordinate system. Also, you can go to the coordinate system manager you can create a new coordinate system if it's not exist. For this project, I will select the UTM zone 38 north, which is the zone we work on it now. For the geoid model, if you work in Iraq, you have the built-in Iraq EGM 1 minute GGF. You can use it. It's already included in the software. If you are outside Iraq, you can use external geoid model. It supports the Trimble GGF format. Also, if your project has a vertical adjustment value, you can include it here. If not, you can keep it unselected. So now you can see here we have the real coordinate and our coordinate system information. Any step you do, you should save the project so you don't lose your information. The second thing is you can create the database, new database, or if you already have a database, you can select a database. So you can, for example, I have a project, I can select, or I will create a new empty database. It will make a new SQL database. Let's keep it in the same folder as our project. If you have a new field or new tables you want to include with the new database, you can include it and you select the table type. If you create a new one without any new tables, it will only create the post-plot and the preplot default tables. So now we have the database, we have the selected database also, and we have the coordinate system information here. Also, you have to save the project to use it. Now we have both. We check the setting. We check the setting. From here, from the setting, you select your project type. For example, my project will be a 2D project. The azimuth type is calculated or manual. The calculated, it means the azimuth will be calculated from the preplot points. No need to enter any azimuth, or you can use the manual and you put the receiver azimuth and source azimuth. For me, I will keep it as calculated. The bin digits, as you know, is the how many digits your seismic point has. For example, if your point is 1001, this is the track, so it's 4 digits, and the bin is 4001, it's the bin digits. Most of the projects has the four bin digits, and some has 5 or more. Here the minimum offset distance to draw a link, we select 5 meters. This is to the link between the preplot and postplot points. Here the checkpoint setting. What is it, the accuracy required for the checkpoint to be accepted or not? For example, we usually use 20 centimeter horizontal and vertical. So this is the checkpoint setting. When we go to checkpoint, we see if it's accepted or not. It will be based on this criteria. Other QC criteria we have is the number of satellite must be more than a specific number, the BDOP, ebook number, survey mode, and for example now ebook we are using 3, survey mode should be 3, vertical and horizontal accuracy is 2. Other thing is the show QC failure marks on map. We always keep this checked. So if any one of these criteria failed, it will show a marker on the point that this point doesn't meet our criteria. Also, we can mark point inside exclusion zone if we already uploaded exclusion zone. Also, we can check this calculate dim deltas. Later, I will explain to you or show you how you can convert a TIF DM to a binary dim, and you can use it here for conversion. Here is the supporting file. I will explain to you one by one what is the meaning of each one later. Also, here is the layer control. From here you can add any specific layer that you have, for example your project boundary, and you make the full color, for example no color, and this will be saved only as a base layer, so you can know exactly where is your project. And you can add exclusion zone. If you select make this like this, it means you convert the layer to an exclusion zone. If you turn it off, it will be just a layer. Also here the postplot point, we use usually the green point, the green icon, and for the matching preplot point we use the red color. If you want to show the preplot source and receiver point that you have in your supported file, you can show it from here. You on and off this this controller. Okay, so after you finishing all the setting, you also save the project. The next step is I will upload a preplot SPS file to our database so we can use it as a controller or a conversion reference file. To upload any coordinates file, you can use SPS format or CSV format, and you can use the ASCII importer to upload it. So you go to ASCII importer. Right now I have the files in CSV format, so it's a preplot in CSV, station value, local easting, northing, height, and descriptor, and same for S. So what I will need is to use the CSV and click add file. I will select these two files. From here I will open the preview. I click on the first row, valid row, and use selected. Then I will start to use the station value C1, local easting C2, local northing C3, the height is C4, and descriptor is C5. If you want to save this format for future, you can save it. You call it CSV, for example, point, easting, northing, Z, and descriptor. Here you put the processor name, for example, it's Ali. Everything, the database, it's already selected, so we will upload this information to the preplot database. Okay, here is the export option. So I will upload this record to the selected database. I will upload it to preplot. If I want to make a shape file, KML point, reference file, you can make it directly from here. I will say update export. So now we already have all our preplot ready. The next point what I will use is the in supporting file. If I have already a reference file in the same format I show you, we can say attach as file, or I will say attach generate as from database. So it will generate a CSV in the same project folder, a CSV with all point that has S descriptor, and I will generate R from database also. It will generate and select. This our conversion is the reference file that we will use it when we compare our points, post-plot point to the preplot. Other thing I can attach is the base station file. The base station also should be in CSV format. I will show you. It will have the name, latitude, longitude, and WGS height. So for the base station, it's name, latitude, longitude, and WGS height. But for the checkpoint, it will be name, easting, northing, height, and descriptor. I will attach both files. So it's the base station. These are reference station, checkpoint. Also, I can attach the surveyor name and processor name for later, to use them later. I will show you how to use it. It's a simple CSV file, has a list of names. Like here is the surveyor, and for example, this is the processors. We will use them later. So I can attach surveyor name, attach the processor name. If you have offset region table also, you can attach it. I already have one here, simple one. You can make your table, your own table, and you attach it also. The last thing is attach a DEM file that we should use it when we make the dim deltas. So I can also attach it from here. I already have one, and later I will show you how to create one. So now I have all the supporting file that I need, so I will just save the project. If I need any other preplot file, I can attach from here, attach other preplot file. Until now, our project is ready. We can use it for the processing the GNSS data. Everything is ready now, the database, the coordinate system, the supporting file, and the settings. So I will end the video up to here, and later we can continue.